Hi everyone and welcome back to PrepFusion. So this question came on GATE 2025 for GATE ECE aspirants from control systems. This is one of the good questions of the paper, and this topic generally is neglected by students. They just study the easy portions and they neglect the this is not even from the difficult portion, right? They have asked a question fundamentally. So what they have given you this state representation, and they have given that x1 x2 x3 are internal state signals and u of t is the input signal, and then they are asking which of the statements is slash are correct. So it depends whether it is msq or mcq. Okay, I don't know, but anyways here only one option will be correct. Okay, so that one option is this one, that there exists a bounded input such that at least one signal is unbounded. And how is this correct? So we will solve this step by step. So if you see, this is the system matrix A, right? This is the system matrix A. So you don't even have to find out the location of the poles. Just write the state equations properly. So my first equation is this one. My x1 dot of t is equals to 2x1 of t plus u of t. Then I have another state equation, x2 dot of t equals to minus 2x2 of t plus u of t, and my x3 dot of t equals to u of t, because the last row is totally 0. So this is the equations, right? Now what you can do, you can take the Laplace. You can take the Laplace transform. If I take the Laplace transform, then I will be able to solve this differential equation. So this will be s x1 of s minus x of 0 equals to 2 x1 of s plus u of s. Now I can take this x1 of s common. So this x1 of s will be equals to then x of 0 divided by s minus 2 plus u of s divided by s plus s minus 2. Okay, now let's assume, let's take for the option 1, there exists a bounded input such that signals x1 x2 and x3 become unbounded. So let me take a very basic example, that my input is u of t is step itself. Okay, then what will be u of s? It will be 1 by s. Now if I rewrite this equation, right, anyways, if you don't even assume any input for any input, right, if your x of 0 is not 0, then it will be always unbounded. Why? Because when you take the Laplace transform, there I will get a e raised to power 2t term. This also, when you will take the Laplace inverse Laplace, you will get a e raised to power 2t term. That e raised to power 2t will obviously be unbounded for t tending to infinity. So from here I can definitely say that for any bounded input, right, my output will, one of the state variables will always be unbounded. So this statement, there exists a bounded input such that signals x1 x2 and x3 are unbounded. Okay, but they are telling all the signals will become unbounded. Is that true? I have to check. Is that true? I have to check. Yes, it is correct. For a bounded input, I am getting one of the signals is unbounded, but I have to check for the other state variables as well. So if I check the other state variable, let's check for this state variable. If I check for this state variable, basically my x3 of s into x3 of s is 1 by s if it is unit step. Then here it becomes 1 by s square. So for this bounded input, it is correct that I will get unbounded output. But let's check for any other example. So let me check for this finite duration signal, right? Because that is also a bounded input. Let me check for this signal. Let's assume it is a signal like this. This is t equals to 2 and t equals to 0. This is my input u of t. Okay. Is this unit step? No. This is what? This is u of t minus u of t minus 2. I hope you study this in signals and systems. So this is your input. I know you are getting confused with this u of t and the input. So don't get confused. This u of, let me mark this as start t, right? This is the input and this is just a u of t notation for unit step. Okay. So now if I write here, what will be the Laplace transform of this? So if I write here, the Laplace transform will be 1 by s minus 1 by this you can write as e raised to power 2s divided by, oh, not e raised to power minus 2s divided by s only. Okay, this is what you can write. So now if I divide by t, this will also become unbounded, or this will not be. So if I divide by 3, this will be x3 of s, okay, and this will be t u of t basically, minus. So the inverse Laplace of this, what will be the inverse Laplace? Actually this should have been 1 by t, sorry, this should have been t ut, but here I have e raised to power minus 2s multiplied, so t will be replaced with t minus 2. So here I will get t minus 2 into u of t minus 2. Now there can be two things here, right? If my, like, for t less than 2, for t less than 2, that means this will be 0. Why? Because u of t minus 2 less than 2 will be simply 0. I hope you know this. If this is 0, then my signal will be only this. So basically my x3 of t, right, this is not x3 of s, this is x3 of t. My x3 of t has two definitions. It is also a, like, a finite duration signal, or not a finite duration signal but a bounded signal only. It will have, it will be equals to t u of t for t less than equals to 2. It will be equals to 2 u of t minus 2 for t greater than 2. So I hope you understood this point. Now is this unbounded? No, right? If my x3 of t was only t u of t, that means then obviously at t equals to infinity it would have been unbounded. But this definition is only valid till t equals to 2. After that I am getting some constant which is not unbounded, right? It is bounded. It is bounded. It is not unbounded. So that's why the option D will be correct and all the other options will not be correct. Okay. So I hope you have understood the point why this option will be correct and why the other options will not be correct. Now why? Because there exists a bounded input, yes, for which at least one of the signals will be unbounded. This is the example, right? Here you will get a term when you will do the inverse Laplace e raised to power 2t, then your signal will go unbounded. So then there could be that problem. Okay, so the signal will be unbounded due to this e raised to power 2t, because at t equals to infinity this will be unbounded. But for this type of signal, right, even though my input was it was unbounded, so not unbounded, it was a finite duration signal. Even though my input was finite duration signal which is bounded, my output is also I am getting as bounded only. It is not finite duration signal, but I am getting output as bounded. Now if you have doubt regarding this one is the simpler one. If you want to solve this, right, this also you can solve. So here how will you solve this one? The second equation, that is, so if you want to solve the second equation, simply you will do, again take the Laplace transform. This will be sx2 into x2 of 0, then equals to, here I will have minus, this time it will have minus x2 of s plus u of s. So this is correct, right? Yes. Now if I just take the like terms, this will be s plus 2 equals to x2 of 0 plus u of s. So your x2 will be x2 of like this is x2 of s, actually not like this. So your x2 of s will be x2 of 0 divided by s plus 2 plus u of s divided by s plus 2. Now when you will take the Laplace inverse, like you will get a term as e raised to power minus 2t, that will of course make the signal bounded. Okay, at t equals to infinity this is tending to 0. So that's how the options will be. This question was not difficult, but it was a tricky and very fundamental questions. So what GATE are doing, they are asking questions from very basic things. They are not telling you to remember any formula. They haven't asked you to remember that formula, that your transfer function will be c si minus a inverse into b. They have not asked that. They have simply asked from the internal state variables. So they are asking questions from basics. So I hope you have understood this question. Thank you for watching, and if you have any other doubts, you can join our Telegram group for further information.